Okay, everybody, welcome back here. Another quick chemistry video up on tap for today. A couple of properties of atoms that we talk about a lot, which is atomic number and mass number. Now, sometimes atomic number is abbreviated with a Z, and mass number is sometimes abbreviated with an A. We're going to talk about what they are, what we do with them, and how we could calculate them. So here we go. Let's get started. So obviously here, if we're talking about these things, we're talking about the atom. So it will take a moment here and go back and talk about the parts of the atom, which hopefully you know by now, but just in case you don't, we have our nucleus, fairly badly drawn circle there. Inside our nucleus, we have our protons, which are positively charged. We also have some neutrons in there, which have no charge. And out from the nucleus at some distance, in that kind of empty space, is our electrons, which are flying around there. Electrons obviously being negatively charged, and they are flying around pretty randomly there in that empty space around the nucleus. So really all atoms are composed of those three subatomic particles: protons, which are positively charged, neutrons, which have no charge, and electrons, which are negatively charged. By the way, as you might also know, it is actually the neutron that is actually the heaviest of all three of those particles. Protons super close to mass, with the electron being about 1800 or so times less massive than a neutron or a proton. So atomic number, mass number, these relate obviously to our subatomic particles. So let's talk a little bit about that. We'll start with our atomic number. Our atomic number is the number of protons in an atom. And that is the definition of atomic number. It will tell you the number of protons there are in an atom. You can actually find the atomic number on our periodic table. So here, if I drew my box from a periodic table there, we got a little iron, which is Fe, little 26 there, number up on top. That right there is our atomic number, or again, sometimes called Z in abbreviation there. And that does tell us the number of protons there are, for example, in iron. So if we had iron, it would have 26 protons. Now, what the atomic number will also tell you is if it is a neutral atom, like for example, this one right here, we do not see any charge. That is right about there where we would see a charge if it was written. So we see nothing there. We assume that it is neutral. And because of the three particles that are in an atom, our protons, which are positively charged, our electrons, which are negatively charged, and our neutrons, which have no charge, these are the only two particles that can affect the charge, which means in this case, because there are 26 protons which are positively charged, there has to be a matching number of electrons in this case, which are negatively charged. So if you take like 26 positive things and add them to 26 negative things, you end up with 0 for the charge, and that is how come we know it is neutral. So a very common mistake that people make sometimes with atomic number is they think the definition is the protons and the electrons, and that is not the definition of atomic number. It is actually just the number of protons. It will tell you, though, if you're dealing with a neutral atom, the number of electrons that are present. Now, we also have mass number, which is actually the number of protons plus the number of neutrons. And when we look at the periodic table, another very common error people make, for example, go back to our friend iron here, 26 up on top. On a lot of people's periodic tables, maybe a 55, 85 written there on the bottom. A lot of people will look at the periodic table and go, that's the mass number. And you will get a big X probably on your paper if you do that. That is not the mass number. That is the atomic mass, which is slightly different than the mass number. What confuses a lot of people is that atomic mass, which is based on protons, electrons, and neutrons, the masses of those guys, is very close a lot of times to the mass number sometimes people are looking at. So they automatically think that maybe they just kind of rounded that number. And that's not the case. So that is not the mass number. Only the atomic number up on top is really the only number that you can get from the periodic table. You cannot get the mass number there from the periodic table. So the mass number is the number of protons and neutrons in an atom. And that's really good because if you take the mass number and you subtract it from the atomic number, that will give you the number of neutrons. So if you take the mass number minus the atomic number, you could actually get the number of neutrons. So let's just say, for example, we had iron 56 and here 26. This, by the way, is a very common way that people write isotopes. And isotopes are the same element, but different masses. And why do they have different masses? Well, it's because they actually have different numbers of neutrons. So because these are the same elements, they will have the same number of protons. And that's a really important point to also think about when you look at, for example, the periodic table and the atomic number. You look at another element, for example, and we'll just do hydrogen there, which is 1. That is hydrogen's atomic number, which is 1 proton. We look at our friend there, carbon. Okay, practice drawing boxes here. There we go. 6 and a C for carbon. It has 6 for its atomic number, which is the number of protons. If you look at a periodic table, which you might have in front of you right now or somewhere near you, every single number that's on top of the element, every single atomic number is different for each element. So if you know the atomic number, or you know the number of protons, which is exactly the same thing, you basically know what element you're dealing with. Or if you know the element you're dealing with, you can very simply go to the periodic table and find the atomic number up on top of it, and that will tell you how many protons there are. So when we talk about protons, electrons, and neutrons, it is actually the protons, which basically tells you what element you are dealing with. So it is actually the protons tell you the number of elements you're dealing with. So when we write an isotope like this, because they are the same elements, they have the same number of protons, but they have different masses. They have different masses because, again, they have different numbers of neutrons in this case. So this is typically the way sometimes isotopes are written, and top left there is the mass number. Bottom left is the atomic number. So that is a very common way that we sort of write isotope symbols with their mass number and atomic number present. So if we were going to do this for iron, the number of protons in this case is going to equal 26, which is the atomic number that we see there, right about there. And I'll put a little plus next to it to remind us that protons are positive. Once again, here we have no charge written, which means I know exactly the number of electrons that make that up, which is 26. That gives me 26 negative electrons plus 26 positive protons. That gives me 0, which is the overall charge in this case. Now about my number of neutrons. My number of neutrons here, top number, mass number, 56 minus bottom number, atomic number, gives me 56 minus 26, going to give me 30 for the number of neutrons, which basically have no charge. So when you do calculate the number of protons, the number of electrons, the number of neutrons, the mass number, or the atomic number, they all typically need to be whole numbers. And that is something that you can remember to help you not make that common mistake of thinking that is the mass number. Because if you look at the atomic mass on the periodic table, which is pretty much the number underneath each of the elements, they're pretty much all decimals. There's very few that are whole numbers. That's a good way to remember it. So mass number, atomic number, protons, electrons, neutrons. If you're trying to calculate any of those, they all got to be whole numbers. Now, to finish this kind of quick up here, we're going to talk about something with charges and what happens in that particular case. Remember in a previous video there, we talked about maybe charges and ions. Ions are things that do have a charge. There again is two types. There is a cation, which is positively charged, and there are anions, which are negatively charged. So how is it affected, the protons, electrons, and neutrons, when we do have something with a charge? We will take our iron example here, and we will give it a +3 charge. And we'll actually use the same numbers that we had there, 56 for our mass number, 26 for our atomic number. So in this case, once again, if we want to do our number of protons, it is going to be 26, which is based off of our atomic number. Once again, I'm just going to put a little positive sign next to it to remind us again that it is positive. Once again, in this case, our number of neutrons, like we calculated previously, is our mass number, 56, minus our atomic number, which is 26, and that is 30 for neutrons. Now we come to our electrons. So in this case, though, we do have a +3 charge, and that means that we're dealing with a cation in this case. So in this particular case, it will actually have 23 electrons. Why does it have 23 electrons? Well, let's just do the math. If I take 26 positive things and add 23 negative things to it, I'm left with a +3 left over. And again, that is where the charge comes from. So it's actually the number of electrons that change when somebody gains a charge. It cannot be the number of protons, because as we talked about, the number of protons pretty much tells us what element it is. So if I were to change the protons from 26 to say 30, for example, then I'm no longer dealing with iron. I'm now dealing with zinc, because if you look on the periodic table there, zinc is number 30. So again, we cannot change the protons because we changed the element. So the only thing that can change is the number of electrons when we get a charge. And that's because neutrons, again, have no charge, right? So they're neutral. So they have no charge. They won't affect the overall charge here. How did we get to a +3? Well, if we come back and look at just our iron like we did on the previous slide there, with no charge, our number of protons was 26. Our number of electrons was 26. And the difference between our neutral iron and our iron with a +3 charge, as we can see, is the number of electrons. It actually lost electrons, which is basically how you make a cation. It will lose electrons. That's pretty much what the charge means here. Positive, lost electrons. The number, how many from the neutral. And we can see that there. +3 means from the neutral guy in this example that had 26, we lost 3 electrons, and now we're down to 23. In this case, you basically now have more protons, which are positive, than negatively charged electrons, which are negative, and that's what's going to give you that overall positive charge. What happens if we have a negatively charged guy? We'll take oxygen, for example. We'll just do oxygen with no charge, and why don't we just do oxygen 16 and 8. And by the way, if we look at oxygen on the periodic table, again, it has an 8 up on top, which is our atomic number, which is right there. Once again, our top number is our mass number, and there's our atomic number. And let's do a neutral oxygen here to start with. So our number of protons going to be 8, once again, equal to the atomic number. Once again, no charge there. So our number of electrons will also be 8. That's going to give us a grand total of 0 for the charge, which is basically what we got going on there. Nothing written. Now, if we take oxygen, which is really oxide in this case, and give it a -2 charge, we'll use the same numbers here. By the way, our number of neutrons in this case, 16 minus 8, which is 8. We will look at our number of protons there, also going to be 8. Once again, cannot be any other number, otherwise it's no longer oxygen in terms of protons. Can never change the protons, or you change that element like we've been talking about. In this case, our number of neutrons going to be 16 minus 8, which is 8. And now our number of electrons in this case is actually going to be 10 electrons. 8 positive things plus 10 negative things leaves us a -2 left over. And once again, that is where the charge comes from. It is the electrons that basically affect the charge when somebody gains a positive or negative charge. How did it change from its neutral? Neutral guy had 8 electrons. Oxygen with a -2 charge, or oxide, 10 electrons. It gained 2 electrons from its neutral set. And that is how we make anions. They gain electrons. And once again, the negative means that it has gained electrons. When you see that negative charge, the 2 is how many electrons it has gained. Again, 8 to 2, 2 electrons gained. So that is how we make anions, which is our negatively charged guys. Typically, our cations will become from metals, is typically the ones that make cations. Anions usually are coming from non-metals. Pretty much here, every element will have protons, electrons, and neutrons, except for hydrogen. Hydrogen actually only has 1 proton and 1 electron, no neutrons. Every other element will have protons, electrons, and neutrons. When you're asked these type of questions, you should have enough information to calculate the mass number, atomic number, number of protons, electrons, and neutrons. And again, they all should be whole numbers. Well, I think we will wrap it up there. Maybe one last thing here I just thought of before we wrap it up. Before we rewind it, maybe we'll take it out in post-production. Probably not. We'll leave it in. Why not? All right, so one last thing, again, as we talked about, very commonly when we do write the symbols with the mass number and atomic number on them, like I did there in these examples, mass number up on top left and atomic number bottom left. Also, sometimes isotopes are written like this, copper-64. That 64 is the mass number, because we know when we go to the periodic table, we cannot find the mass number, but we can definitely find the atomic number. And boom, right there is the atomic number for copper, which is 29. So I definitely know that that is not the atomic number. If I were going to turn that copper into our other version of writing this, we would go 64 up on top, 29 on the bottom. And once again, this guy here with no charge, the copper, would have 29 protons, matching number of electrons, 29. And again, if we subtracted our mass number from our atomic number there, we will end up with, I'm going to try off the top of my head there, something like 35 looks about right there. Tried it with no calculator. I threw it somewhere. All right. Well, I think that really does wrap it up here for this quick video. I hope it's helpful. I hope you learned something about atomic numbers, mass numbers, protons, electrons, and neutrons. Once again, let me know in the comments if there's some other topic you want kind of a quick once over video on. I'll be happy to try to do that. Other than that, we'll see you on the next one. Thanks for watching. Bye-bye.